So moving into the second guided practice problem. If 42 grams of metal at 320 degrees Celsius is placed in a 268 grams of water at 33 degrees Celsius, the temperature of the water increases to 45.9 degrees Celsius. What is the specific heat of the metal? Okay, so again, they give us a nice little chart to work this out on. Just a heads up, they may not always give you a chart. Your independent practice will look just like this, but they may give you a question where they just give you the words, and you're going to need to set up your own chart, all right? So first things first is we're going to change these degrees Celsius into Kelvin by adding 273. So we're going to do 33 plus 273, and we get 306. Alright guys, I'm still getting my emails coming in. And then we're going to do 45.9 plus 273, and you should get 318.9. So that means this one will be 318.9. So I'm going to take the time to show you, if you realize the final temperature of the water and the metal are the exact same, that's because we have reached equilibrium. They have to come to the same temperature. Otherwise, heat will continue to transfer until they get to that same temperature. All right. We're going to do 326 plus 273, and this one is 599. All right. So once we've done that, we can calculate our delta T. Remember, delta T is equal to T final minus T initial. So the final temperature minus the initial temperature. When we do that, for the first one, we get 12.9. Then 318.9 minus 599, you get a negative 280.1. All right. I am done with my final temperatures and initial temperatures, so I'm going to cross them out because I do not need them anymore. Reminder, we're always going to start with water. This is the one that we have all the values for, so this is the one that we can calculate. So starting out with Q of the water is equal to MC delta T. Okay. So the Q of the water is equal to the mass of the water, which is 268, times the specific heat of the water, 4.18, the C, times the delta T of water, which is 12.9. Make sure you're using all the values of water. We're going to plug that number, these three, into our calculator. We're going to multiply them all together. And when you do that, you get Q for your water to equal 14,451.096. All right. So again, the number for the water, or the energy for the water, is positive, which means that it had to absorb heat. And it is absorbing it from the metal, so that means the metal had to release the heat. So we're going to find Q of the metal. We're going to use Q of the metal is equal to MC delta T. Okay. Again, whatever number is here will be the Q for the metal, just the opposite sign, because the water is absorbing the heat that the metal released, right? So release means negative. Okay. If this was a negative number, then this would have to be positive. These always have to be opposite signs. So we're going to take the M of the metal, which is 42. The C of the metal, which is what I'm looking for. Delta T of the metal, negative 280.1. Okay. Again, we're solving for X. You're going to get so good at this because it's going to be so repetitive. I can't do anything with a number on this side of the equation, so I just write it down again, equals, I can take these two numbers and combine them together by multiplication. I'm going to multiply them together and you're going to get alright, so -1 or negative 11,764.2, and you still have your x over here. Now I need to solve for x. In order to do that, I need to get rid of the number that is next to x. Remember, these are being multiplied together, so to get rid of this number, you must do the opposite of multiplication, which is division. These are going to cancel out, leaving you with just x. You are then going to plug this into the calculator. The top number divided by the bottom number. Remember, the top goes in the calculator first. You plug that all in and you get x equals 1.23, and it's the specific heat, right? So here's your units. Joules per gram degrees Celsius. Again, when you're doing your independent practice, do not enter in the units. Okay? All right. We're going to move on to our